Hi, I am Mário Vilas Boas, and this is a lecture about facts about global warming that most environmentalists don't know about. This is part 2, myth busting. In this part, I will analyze some of the statements of environmentalists about global warming and see whether they are or are not in accordance with the scientific data which are available. If you haven't seen part 1 prior to watching this video, you are strongly advised to do so, unless you have a strong background in physics or engineering related matter. It will be hard for you to understand without watching part 1. You need also to have some background in statistics, so you can accompany my reasoning about this matter. So, let's start. Environmentalists used to say that carbon dioxide concentration has been increasing consistently in last years. 2. That burning fossil carbon is a relevant source of atmospheric carbon dioxide. 3. Mean temperature of the Earth has been increasing constantly in last years. 4. The increment of atmospheric carbon dioxide concentration causes global warming. And 5. An increase in Earth's mean temperature will cause climatic catastrophes in the future. So, we'll analyze each of those statements and see whether they are likely to be true or not, if there is scientific support of each of them or if there is not. Let's start. First, we'll analyze the evolution of concentration of carbon dioxide in the atmosphere. Mauna Loa Observatory in Hawaii has been measuring the concentration of carbon dioxide in the atmosphere since 1957. And this figure and the raw data about it is disposable in the page, so that anyone can not only see the picture but make his own analysis. And we shall analyze those data. If we take the mean in annual basis of the concentration, we will see this graph you see here. You can see there is not a straight line that can represent these points. However, a second degree parabola will fit quite well, as you can see in this picture. Well, in a correct analysis, we should use the mean deviation, standard deviation, to see the interval of confidence. A criterion which is widely used is the criterion of 95% of confidence. For having 95% sure that you are close to the truth, we should put the mean plus 2 times standard deviation or minus 2 times the standard deviation. So we have an envelope which have 95% of confidence. See the picture. You see 2 curves. The range between the 2 curves are the range of 95% of confidence. That means I don't know for sure what's the real function that represents this behavior, but I can believe that 95% of the points of this curve, whatever it is, will fit within this interval between these 2 curves you see in the graph. That's the concept I am using. You see that this range is very narrow, so that even though there is an oscillation, that this curve does not follow exactly the curve we have seen before, if 95% of the curve is within this range, you can quite confidently say that this is a rising function. That means the concentration is actually increasing with time. So that the statement that carbon dioxide concentration has been constantly increasing the last year is true. That means if the last years mean from 1958 to 2016. Okay, so this statement is true. So let's go to the next one. The next one is about the source of this carbon dioxide. Okay, we have seen that the concentration is increasing. Something is adding up some carbon dioxide to the atmosphere. Where does it come from? Environmentalists say that it's mainly coming from burning of fossil fuels by mankind. Is that reasonable? Let's see. Here we see the figure again, the same figure we have seen before. But let's look this in detail. Let's take a small part of this curve and amplify it to watch in detail, like you see in the picture. You can see that although in the mean of the year the concentration is increasing, there is a season of the year where the concentration decreases, and every year. So let's think a little about that. Do we change the burning of fossil carbon during the year? No, it's not true. We burn throughout the full year. So if we burn throughout the full year, why there is a season in which the concentration decreases? That does not make sense. If this extra carbon dioxide comes from burning fossil fuel, so it would not be reasonable that there is a part of the year in which it decreases. Does not make any sense. But let's go further. Let's see some important numbers. The amount of fossil fuel that is burned in 1 year is about 6 billion tons a year. This number refers to year 2010. There are already some more recent data about that, but I have this in hand. I will use this one. Maybe nowadays maybe a bit higher than that, but not too much higher. 6 billion tons of carbon per year. The amount of carbon dioxide which goes to the atmosphere through respiration, not only human respiration, but through all organisms, is 120 billion tons per year. This is the amount of carbon dioxide that goes to the atmosphere through respiration. How much carbon there is in atmosphere? It's about 820 billion tons. And there is another important number. It's the amount of carbon dioxide that is dissolved in ocean water. It's 38 trillion tons. Okay. First thing, this is the amount of carbon in form of carbon dioxide. This is not the amount of carbon dioxide. If you don't know the difference, I refer to part 1. Watch part 1 to see the difference. So this is the amount of carbon. Why the carbon in ocean is important? It is important because the amount of carbon in atmosphere is in equilibrium with carbon in ocean. There is no barrier that impedes carbon dioxide to go to ocean, to atmosphere, or to atmosphere to ocean. So the amount of atmosphere that we deal about is not the one in the atmosphere, it's also the one in the ocean. So this is the total amount of carbon dioxide that we deal with, atmosphere and ocean. So now these numbers are so enormous, so great, so outside of the human scale, that's difficult to reason about that. So let's see a graph. Look at this graph. In this graph, we see the amount of carbon that is burned by mankind during the year 2010, the amount that living beings produce from respiration, and we see also the amount in the atmosphere and the ocean. The amount in the atmosphere and the ocean is outside of the scale. We were just comparing the amount that goes from respiration, the amount that is burned by mankind. You see that the amount that goes from respiration is 20 times as big as the amount of fossil fuel that is burned by mankind. That's something to think about. So the amount that is burned by mankind is so relevant. It doesn't seem so, because the respiration is 20 times as big. Now let's change the scale so we can see the amount in the atmosphere. Look at this picture. Now you can see the amount of carbon in the atmosphere and compare it. It is produced in 1 year for respiration and by burning from mankind. You can see in the graph, you see that the amount of atmosphere is really enormous. Look at the amount of the burning of carbon dioxide. This is minimum. And the amount in ocean is still out of the scale. So let's use another scale so we can see the amount which is in the ocean. Look at this picture. The amount of carbon dioxide which is dissolved in the ocean is about 50 times the amount which is in atmosphere. Think about that. For each ton of carbon dioxide in the atmosphere, there is about 50 tons of carbon dioxide dissolved in ocean. In this scale, we can't even see the amount of carbon produced by burning fossil carbon by mankind. Look, it disappears in this scale. So, is it reasonable to think that this amount that we cannot see in this graph is responsible for increasing this amount of carbon in atmosphere and ocean, because there is no barrier from atmosphere to ocean? This so that we can see this is absolutely not likely. So this statement, burning of carbon by mankind is a relevant source from atmospheric carbon dioxide, is busted. Because first, there is a season of the year in which carbon in atmosphere decreases and mankind burns carbon in this season. And second, as you can see, the amount of carbon burned by mankind in 1 year is absolutely insignificant if you take the total amount of carbon in atmosphere plus ocean. So, the next point is global temperature. Is global temperature increasing or decreasing? Look at this graph. This graph shows the evolution of mean temperature in the last 420,000 years from past to now. We have here the source of those data. This is measured from ice in Antarctica, namely in Vostok Lake, and most of conclusions of environmentalists are within these data. So we can see this point here represents the last ice age, and this outer range in green is the last interglacial period in which we are today. So let's analyze just the temperature in this last interglacial period that has lasted more or less 10,000–12,000 years. So this graph, the same data we have seen before, but we take just the last 11,000 years. You can see a clear tendency of increasing or decreasing. Let's make a linear regression so that we can represent that with a straight line. Well, making a linear regression, we will have this straight line you can see there in the graph. Well, at first sight, we could say, well, it's increasing, so it's real, the temperature is increasing. However, look at the upper and lower envelope. That is the region in which we have 95% sure that the function is within it. Okay, so we can place a decreasing curve without going out of this region of 95% of certainty. Look at the picture. What does it mean? This means that with this data, we cannot be sure whether the temperature is increasing or decreasing. It's not accurate enough so we can state the temperature is increasing or decreasing. People say that this is due to the Industrial Revolution. So, okay, let's take just the points from the beginning of Industrial Revolution, by the end of 18th century, up to today. So here is the graph. We have from initial of Industrial Revolution up to today. So these are the data available on this period. We can put a straight line. It is also an increasing straight line, but as in the other case, if you take the range of 95% of certainty, we can place a decreasing curve inside without going out of this range. So, by the same reason of the former one, we cannot be sure of this increasing tendency is real or not, because we can place a decreasing curve inside of this interval without extrapolating this interval. So, the statement that the mean temperature of the Earth is increasing constantly in the last year is unconclusive. That means the available data will not allow you to conclude this or the opposite. Unconclusive is this statement. We are not sure the temperature is increasing or decreasing. Now we go through the relation between temperature and carbon dioxide. We go to that graph again, but we'll compare this graph with the graph of carbon dioxide in the atmosphere in the same period. This was measured in the same work. This is also in this page, and you want to analyze the way it wants. Here you have. Look into the graph. We can see that whenever we observe an increase in temperature, we observe also an increase in carbon dioxide in the atmosphere. Whenever we have a decrease in temperature, we also observe a decrease in carbon dioxide. So, saying that, we can state that increasing carbon dioxide in the atmosphere will increase temperature. Is that right? No, this is wrong. Looking at the graph, you can see that even though the interval of 95% of confidence is not very narrow, it's narrow enough so you can see that this relationship between those two are real. This is real. This is not a fake. Okay, there is a relation between one and other, but this is not enough to state which one is cause and which one is consequence. There is also a third hypothesis, which will be that there is a third cause that causes simultaneously both effects. That means increasing temperature and increasing carbon dioxide are both effects of a third phenomenon, which is not here. But we shall not analyze this possibility. We will analyze only the two possibilities, that one is cause of the other, or the other is cause of the first. Which one is cause, which one is consequence? How can we state that? Well, to state that, we look at this and see, well, the cause happens before the consequence. So, if one of those phenomena happens before the other, so the one that happens before is the cause. The one that happens after is consequence. Simple. So, how can we be sure which one of those happens before the other? That's the tricky thing. So, we have this graph correlating temperature and carbon dioxide in the atmosphere in the same time. Let's now make a shift in time. We will correlate temperature and carbon dioxide in different times with a shift in time. And we shall measure the standard deviation of the correlation. The one with the lowest standard deviation is the best correlation possible. Look at the graph. This graph shows the standard deviation according with the shift in time. And you shall see, looking at the graph, that the lowest standard deviation we can see here in this graph happens with the shift in minus 800 years. That means when we correlate carbon dioxide in the atmosphere with temperature that has happened 800 years before the carbon dioxide in the atmosphere. This is the best correlation we have. Now, we shall see here in the graph. Look, this graph is the one we have seen before, correlating temperature with carbon dioxide in the same time. This other graph represents temperature and carbon dioxide with a shift of 800 years, so that the temperature has happened 800 years before carbon dioxide in the atmosphere. Look into the graph. We can see that the one in the bottom with the shift of 800 years represents better than the one in the up. So that this proves that those two phenomena are related. However, the carbon dioxide responds to Earth temperature of 800 years before, not at the same time. If the temperature, the shift in temperature happens 800 years before than the corresponding carbon dioxide in the atmosphere, so which one is cause, which one is consequence? Of course, the shift in temperature is the cause, and carbon dioxide in the atmosphere is consequence. So, the statement that the increment in carbon dioxide in atmosphere causes the increment in global temperature is busted, because the cause-effect relation between those two, they do exist, but they are inverse. That means that increasing temperature will cause an increase in carbon dioxide in the atmosphere, not the opposite. This is what we can see using the very data that environmentalists use to try to convince us to the contrary. Well, let's go to the last statement. The last statement is about climatic catastrophes. If the temperature increases, there will be some climatic catastrophes for mankind. Well, this statement cannot be proved. We can only see if these catastrophes will happen or not when this time comes. The time comes that temperature is high and the climatic catastrophe is occurring. And we shall never be sure that the cause of this climatic catastrophe will be this or some other thing. So we cannot prove that. But what we can see, we can look at the past and see what happens in the past when temperature was different from actual. Look at this. This is the same data. I always using the same data that environmentalists use. This graph shows the temperature in the last 1,000 years, from the year 1000 to the year 2000. And we can see, according with this data, there was a period between the end of 16th century and the beginning of 17th century, in which the temperature was above it was nowadays. The maximum was about the year 1600, in which the temperature was more or less 1.5 degrees centigrade above the temperature today. This is, in this data set, the same one that the environmentalists use to try to prove us their point. Now, the year 1600, it was in the historical times. That means we do have some historical records of what happened in this year. Do we have some historical records about this period that appears some climatic catastrophe anywhere in the world? I don't see. I don't know of any. What has happened in this period by the end of 16th century and beginning of 17th century? But this time was the time that Spanish was conquering North and Central America and Portuguese was conquering South America. French and Dutch were trying to have their share. They have not succeeded very much here in America, but they succeeded in other parts of the world, in Africa and Asia. They took a share there. By this time, Portuguese were taking spices from Asia to Europe. By this time, sugarcane has been introduced to America, and there was a heavy trade of sugar between America and Europe. But this time also, there are heavy trade of slaves from Africa to America. That means all those trades were made of those ships. Ships by that time that were not very safe ships. They were crossing all the oceans of the world. So could those ships cross the oceans with climatic catastrophes happening everywhere? Is this reasonable that those ships have been crossing this intense commerce throughout the whole world with climatic catastrophes? This is not reasonable. So this has not happened in this period in which the temperature was above the nowadays temperature. So what may make we believe that if this happen again, the climatic catastrophe will happen? Which evidence we have? We have no evidence that will support this. So, this last evidence, an increase in Earth temperature will cause climatic catastrophe in the future, is not plausible. We cannot say that this is false, we cannot bust them, But this is not plausible because this has already happened in the past and no climatic catastrophe has been observed. It's not likely to happen in the future. Well, this is the end of this lecture. These are facts. We cannot deny. If you like it, please share. And now I will make a statement. I make a question for you that have watched up to here, especially if you have watched part 1 as well. The question I do is, given those facts, those are facts, okay? Given those facts, is it worth to spend billions of dollars for decreasing the amount of carbon dioxide we launch in the atmosphere? This is the question I ask you. Thanks for watching. Like and share if you liked it. Goodbye. Till the next.